Okay, class, today we're going to talk about scatter plots. Okay, the standard that we're using, that we're talking about right now is 811A, and it says we're going to construct a scatter plot and describe the observed data to address questions of association, such as is it linear or nonlinear? Is there an association or no association between what we call bivariant data? Okay, so let's just dive off into this lesson and talk about what is a scatter plot. Well, a scatter plot, as you see here, is a graph that uses points to display the relationship between two different sets of data. So we're trying to determine whether or not two things actually are related to each other or not. And then each point can be represented by an ordered pair. So if you look at the graph that we have below, it says that in this particular one, we're comparing ages of trees and the diameter of that tree. Okay, so you'll notice our x-axis here is represented by our age in years. Our y-axis is talking about the diameter of the tree. So what we're trying to figure out is, does the age of the tree, does that determine the diameter of the tree? Okay, so is the diameter dependent upon age? Okay, so if you look at this particular graph right here, you'll notice that it looks like as a tree gets older, the tree gets fatter. Okay, it gets a greater diameter. That's what we call a relationship. Okay, matter of fact, it's called a positive relationship. So if we look at this one red dot right here, this red dot represents a tree that's 25 years old, and that tree is 8 inches in diameter. So looks kind of like as the tree gets older, it gets bigger. Okay, so let's continue to talk about scatter plots then. Okay, so let's see if we can answer a few questions here about some scatter plots. Okay, just to kind of see if you understand what's going on. It says the scatter plot shows the ages and sleep times of several people. Use the scatter plot to classify each statement as true or false. What you have to be able to do with the scatter plot is determine relationships and then answer questions about the information provided. So take, for example, it says 2 people slept for 7 hours. So did 2 people sleep for 7 hours? So we come up here to 7 hours and we work our way across. We find out that yes, 2 people did actually sleep for 7 hours. So that would be true. Okay, then we look at the next one. 5 people over the age of 12 were in the group. So we look down here on our x-axis and we look at 12. We go up. Did we have 5 people over the age of 12? No, we did not. We only had 4 because this one is 12. They're not over the age of 12. So this one would be false. So last question. Everyone in the group slept for at least 6 hours. So we look at the hours slept. Is everybody above 6 hours? Yes, that is a true statement. So when we look at that, back at that standard, it says that we have to be able to answer questions about the data provided in a scatter plot. Now there are 4 things that we need to know about a scatter plot. Okay, 1, raw data isn't perfect. Because a scatter plot, what we're doing is we are graphing raw data. In other words, data that we just collected and we put it on the chart. Looking at the 2 pieces of information, like in the last one there, time slept, and then age and years of that particular person. That's raw data. So we go ask a person, how old are you? How many hours did you sleep? How old are you? How many hours did you sleep? Raw data. And raw data isn't perfect. Okay? The second thing, scatter plots are used to analyze raw data. So when we graph the data, we make determinations based on it. We analyze it. Number 3, we never connect the dots in a scatter plot. They're not meant to be connected, so we don't connect them. Right? And then the big one, number 4, correlation. This is the biggest word that we have to understand today. Correlation is a word that we use to describe how the data is clustered or how closely the 2 quantities are related. And we have 3 types of correlations that we're going to deal with. We have a positive correlation, okay, which is just like a positive slope. It's going uphill. We have a negative correlation, which means it's going downhill. Or we have no correlation, which means there's no connection whatsoever. So let's look at what these correlations look like. Okay? Here's an example of positive correlations. And you'll notice that we've got a strong correlation and a weak correlation. Positive correlation means as one set of data increases, the other set tends to increase as well. So you'll notice in this one, as our X value increase, our Y value increases. Okay, now this is what we call a strong correlation, because there's a line that fits down through there. It appears to go through there anyway. And the closer all these dots are to that line, the stronger the correlation. Now this one's a weak correlation. You'll notice they're much further away from that line that kind of goes through the middle of it. Okay, then we have a negative correlation. A negative correlation says as one value increases, the other tends to decrease. So as we increase on our X, the Y value goes down. Okay, so this one is known as a weak correlation. This one is a strong correlation because it's much closer to that center line, or what we call our line of best fit. And then you have no correlation. No correlation means that when we graph the data, it's just kind of all over the place. It doesn't appear to have any relationship whatsoever. So let's see if we can identify some relationships here real quick. Okay, here are 6 questions, and I want us to talk about, are they positive, negative, or no correlation? Pause the video and answer, do these graphs represent a positive, negative, or no correlation? Okay, let's see how you did. Okay, number 1. Well, in this one, it looks like the dots are all over the place. This one is no correlation. Okay, this one, it appears that our dots are kind of going downhill, so this would be a negative correlation. Okay, and it would be, not real strong, but not real weak either. Okay, number 3, this one, it appears that the pattern is increasing, so this would be a positive correlation, and a relatively weak one because they're kind of quite a ways away from that center line. Number 4, this one would be a positive correlation, and it's a fairly strong one. Okay, number 5, a negative correlation, and again, a fairly strong one. And then number 6, no correlation, even though it would make a nice, pretty little hexagon. But remember, we're not supposed to connect the dots. All right, now, could we, looking at some scenarios, determine if 2 pieces of information go together or not? Okay, so let's look at some scenarios here. Okay, and I want you to say, is it a positive correlation, negative correlation, or no correlation? Number 8 says the number of hours a person has driven and the number of miles driven. So as a person drives, the number of hours, as it increases, do the number of miles increase? Yes, this would be a positive relationship. Number 9, the number of siblings a student has and the grade they have in math class. No, the number of, this would be not a negative, this would be no correlation. Okay, because it does not matter how many siblings you have to determine your grade in math. Number 10, the age of a car and the value of a car. Well, as a car ages, its value goes down. This would be a negative correlation. Number 11, the number of weeks a CD has been out and its total sales. Okay, well, as when a CD first comes out, or music on iTunes or whatever, as it comes out, people start buying it. Okay, so it goes up quickly. Okay, and then it levels off. So this would be a positive relationship. Okay. Number 12, the number of years a person went to school and their income. Well, if a person goes to school a greater number of years, it should impact their income in a positive manner. So this would be a positive relationship. Number 13, the number of songs downloaded on your iPod or your iPhone or anything like that, and the amount of memory available. Well, the more you have downloaded, the less memory you have. So this would be a negative relationship. Number 14, the amount of time spent on the computer instant messaging your friends and the number of computers in your house. This would have no relationship. Okay, and then number 15, the age of your house and the number of people living in it. The age of your house has nothing to do with the number of people living in it. So no relationship. So what you found is that we've got several different ways of looking at positive or negative relationships. We've looked at it in terms of graphs, determining whether it's positive or negative, or no relationship, or even a strong or weak relationship. And we've looked at some scenarios to determine, is it positive or negative. So that's the first half of our scatter plot lesson. We will have another half coming soon. Until next time.